Have I got a good development for you guys today? A pumped electrolysis cell. Right in there I got a Stanmeyer-esque stainless steel tube and rod cell configuration, and on the right side you can see there I have a power head from a saltwater fish tank. Basically, the pump takes the electrolyte water and pumps it down through the bottom of the tube, and then through the tube past the plates, and the water exits out the top, as well as the gas. Now I'm going to turn on the power supply. We got a computer power supply modified. We're going to start with 5 volts DC. I'll just turn the switch on here. And that's the gas output without the pump on. Just going to get this wire out of the way so you can see better. Now that's without the pump. So I'm going to turn the pump on and you're going to see the difference. Now you see with the pump on, there's a great increase in gas production, and for a very simple reason, and that is because normally during operation of the cell, the bubbles will interfere with current flow across the plates through the electrolyte, because they just simply occupy space both on the plates and in between the plates. So by pumping the water through the cell at a high velocity, which this isn't really that high of a velocity, but by doing that you force those bubbles out of the way, exposing more plate surface to the electrolyte bath than would be if the bubbles were in the way. But since the bubbles are being forced out of the way, the cell can draw a lot more current and produce more gas. Now I'm going to turn off the voltage to the plates so you can see just how much water the pump is actually pushing through the tube. I'm going to get these bubbles out of the way. Now this is just sodium bicarbonate electrolyte. I do that for safety reasons. And you can see this pump really isn't that strong, so I mean, a higher strength pump, you definitely get more gas production using it. The great thing about this is you can even operate the cell out of the water. See, it's producing gas bubbles even though the top of the tube is completely exposed from the water bath. Now I'm going to show you the difference in current draw through the cell alternately with the pump off and with the pump on. This is the current draw with the pump off. You can see we got about 2.45 amps getting pulled through the cell using 5 volts, and that is the gas production, or the apparent gas production. I'm going to put it under the water so you can see the bubbles a little better. Now I'm going to turn the pump on. I'm about to plug the pump in. You see the current just jumped to 3.16 amps. And look at the gas production. So I'm proving here that the increased water flow across the cell is actually forcing it to draw more current than it would without the pump. But you're getting more gas at the same time, so it's not like you're just wasting current. This way, a small cell can produce a lot more gas than would be attainable if it didn't have a pump and the plates were just sitting there in the water. And the amps are pretty stable. In fact, the pump will actually cool the plates down and regulate current draw at the same time, because when you have runaway heat, you get runaway current as well. You could also put a filter pad on the bottom of that pump, and it'll filter out all this orange gunk that's usually associated with a improperly sealed cell. And we're still rock solid at 3.12 over there, 3.12 amps. I guess you could actually build a few of these and run them in series and have a pretty high production series cell. Of course, you'd probably need 3 pumps as well, but the gas output would be huge if you really tweak it and use a really high power pump. This is probably one of the smallest water pumps available at the fish store. So this is already available technology at pretty much any local hardware store and aquarium supplier. And here we are making electrolysis cells out of it. It's pretty amazing. So now I'm going to disconnect the pump and you're going to see the current drop again. I'm disconnecting the pump right now. And you see the current drop back down to about 2.5 amps. So you're getting about an extra half an amp from the pump, but you're also getting a lot more gas. And with a higher power pump, you'll get a lot more amps. Well, now I'm going to switch over to 12 volts instead of the 5 volts as before, and just to show you a ridiculous amount of gas production out of this little cell. So first I'm just going to turn the power on without the pump. See, that's quite a bit of gas in and of itself. There's about a millimeter gap in between those plates in there. Now I'm going to plug the pump in. We're drawing about 9 amps through this little guy right here. And I'm going to connect the pump. And just look at that gas production. Pulling about 12 amps off this thing. I can't leave this thing on for long before the wire starts smoking. They're already getting pretty hot. But that's an insane amount of gas from one little cell. And I can take it out of the water and it's still making gas. I'm going to have to shut it off now before it overheats. But you see the current is rock steady at about 12 amps. Now if this is a normal cell without the pump, this thing would probably be climbing up to 20 amps by now. Now I got the power off and the wires are very hot, but the pump is still going.